All right, let's begin. So, OpenAI has released a very, very interesting new blog approximately 4 days ago on structured outputs. What is structured output? So, right now, if you go and ask ChatGPT to do something for you, it'll most likely just spit out a bunch of stuff. Structured outputs is essentially the ability for agents to output information in a way that is extremely structured. And most especially that correlates with JSON. YAML is probably going to be happening soon because it wastes less tokens and it's just probably more efficient. But mostly now when you hear agentic workflow tools, they all mostly mean in structured outputs. This all means just JSON outputs. That's essentially what it means. People just like creating words to complicate things, I guess, but they're really just talking about the ability for an LLM to generate good information within the bounds of JSON. So JSON mode is a useful building block for developers to look to build reliable applications with our models. JSON mode improves model reliability for validating JSON outputs. It does not guarantee that the model's response will conform to a particular schema. But today, or the other day, they're introducing structured outputs, which does guarantee that the outputs will follow the schemas. So generating structured data from unstructured inputs is one of the core use cases for AI in today's applications. Developers use the OpenAI API to build assistants to fetch information via a function calling, extract structured data for data entry, and build multi-step agentic workflows that allow LLMs to take actions that are completely external. So naturally speaking, LLMs cannot do much other than generate information. They cannot natively do things. They cannot natively send emails. You have to build integrations for these capacities and these capabilities because LLMs cannot natively do this. You have to equip them with the schema to follow in JSON. Then you have to parse that JSON, and then you actually execute that JSON. So you need the LLM to generate JSON. And then once it generates JSON, let's see, JSON. So you need an LLM to generate JSON. Then this JSON needs to be parsed. So LLM needs to generate JSON. Then the JSON needs to be parsed, and then after it's parsed, then you actually execute it. So execution. But LLMs cannot natively do this. LLMs cannot just hop around from here to there. You need these intermediate steps to enable LLMs to take external actions, which is, like I said before, one of the most, if not the most valuable use case of generative AI right now. So if the outputs are not structured, then the information is just going to come very uncleaned and messy, and that's not very useful in production. So they're basically proposing on re-evals of complex JSON schemas. Their new model, GPT-4o 2024 August 6, with structured outputs, scores a perfect 100% in function calling outputs. Whereas in the past couple of months and up until now, GPT-4 scores less than 40%. And so this is a very, very big boost indeed, of 60% in reliability. So with structured outputs, this new model achieves 100% reliability. 100%. So I'm gonna get into how to use the API pretty soon, the new model. But this is a JSON schema. You put in the model name, you put in the messages, and then you get a JSON output. We're gonna be showing this pretty soon. I want to show you. Okay, so this is a cool demo I wanted to showcase. So in this demo, they're dynamically generating user interfaces based on the user's intent. For example, developers can use structured outputs to create code or UI generating applications. One of which is extremely popular called v0.dev. This is an app that Vercel is building, and it is very, very good. I mean, like, extremely good. We've had entire UI specs built and deployed and shipped into production with this platform. Now, it doesn't build the back end necessarily, it builds the front end. And as you can see here, it's really, really good. So I generated this based off of just a simple text description. And this is what's possible here as well. For example, developers can use structured outputs to create code or UI generating apps. This is the system prompts. And then this is the response format here that the agent is outputting, which seems to be React. And so this is going to be the output function, which is just a bunch of classes. And then we could also generate forms. We can generate stock price widgets. And yeah. So the potential for this is very, very powerful because if you can generate UI designs just based off a simple user input, like let's say I want to make an admin dashboard for our analytics service, or you want to make a dashboard, or you want to make like a landing page for your framework, then the agent can now output the entire UI design in a very simple format and very reliably. So this is a complete game changer for like dynamical apps, basically. So if you wanted an app that was fully dynamic, it wasn't really static, this is a very, very interesting use case. So there's a couple of other use cases here, but I want to go into how this works exactly. So we take a first two-part approach to improving reliability for model outputs. First, they train the newest model to understand complicated schemas and how best to produce outputs that match them. However, model behavior is non-deterministic. So it still does not, it reached 93%, but didn't do too good. So they took a deterministic engineering-based approach to constrain the model's outputs to achieve 100% reliability, which probably means they didn't do anything related to the actual model architecture. They probably just parse things in a weird capacity and constrained decoding. So our approach is based on a technique known as constrained sampling or constrained decoding. By default, when models are sampled to produce outputs, they are entirely unconstrained and can select any token from the vocabulary as their next output. This flexibility is what allows models to make mistakes. For example, they are generally free to sample a curly brace token at any time, even when that would not produce a valid JSON. In order to force valid outputs, we constrain our models to only tokens that would be valid according to the applied schema, rather than all available tokens. It can be challenging to implement this constraint in practice, since the tokens that are valid differ throughout a model's response. So let's say this is a schema. Type, object, properties, value, type, required, value, additional properties. The tokens that are validated at the beginning of the output includes things like curly brace string, dash n. However, once the model has already sampled val, then curly brace is no longer a valid token. Thus, we need to implement dynamic constraint decoding and determine which tokens are valid after each token is generated, rather than upfront at the beginning of the response. Now, to do this, we convert the supplied JSON schema into a context-free grammar. A grammar is a set of rules that define a language, and a context-free grammar is a grammar that conforms to specific rules. You could think of JSON and JSON schema as particular languages with rules to define what is valid within the language. Just as it's not valid in English to have a sentence with no verb, it is not valid in JSON to have a trailing comma. Thus, for each JSON schema, they compute a grammar that represents the schema and pre-process its components to make it accessible during model sampling. This is why the first request with the new schema incurs a latency penalty. We must pre-process the schema to generate this artifact that we can use efficiently during sampling. While sampling after every token, our inference engine will determine which tokens are valid to be produced next based on the previously generated tokens and the rules within the grammar that indicate which tokens are valid next. We use this list of tokens to mask the next sampling step, which effectively lowers the probability of invalid tokens to 0. Because we have preprocessed schema, we can use the cache data structure to do this efficiently with minimal latency overhead. So, as you can imagine, this is a very heavy engineering approach. This is not... So basically, the grammar is kind of like a parser. They're parsing for certain things, and if the LLM outputs something that should not be correct, then it'll essentially it'll have to remove everything that is not correct. That's essentially what a grammar means. Now it says alternate approaches. Alternate approaches to this problem often use finite state machines, FSMs, or regexes, generally implemented with finite state machines for constrained decoding. These function similarly in that they dynamically update which tokens are valid after each token is produced, but they have some key differences. Notably, finite state machines or CFGs, can express a broader class of languages than FSMs. In practice, this doesn't matter for very simple schemas like the value schema shown above. However, we find that the difference is meaningful for more complex schemas that involve nested or recursive data structures. As an example, finite state machines cannot generally express recursive types, which means FSM-based approaches may struggle to match parentheses in deeply nested JSON. The following is a sample recursive schema that is supported on the OpenAI API with structured outputs, but would not be possible with a finite state machine. So name, description, strict schema, and then this is the function. Each UI element can have an arbitrary children which references the root schema recursively. This flexibility is something that CFG, which is the constrained decoding, can do, and FSMs cannot do. Now, there are some limitations. Structured outputs allows only a subset of JSON schema. The first AI response within a new schema will incur additional latency, but subsequent responses will be fast with no latency penalty. This is because during the first request, we process the schema as indicated above and then cache these artifacts for fast reuse later on. Typical schemas take under 10 seconds to process on the first request, but more complex schemas may take up to a minute. The model can fail to follow the schema if the model chooses to refuse an unsafe request. The model can fail to follow the schema if the model chooses to refuse an unsafe request. If it chooses to refuse, the return message will have the refusal Boolean set to true. The model can fail to follow the schema if the generation reaches max tokens or another stop condition before finishing. Structured outputs does not prevent all kinds of model mistakes. For example, the model may still make mistakes within the values of the JSON. If developers find mistakes, we recommend providing examples in the system instructions or splitting tasks into simpler subtasks or just making more agents. Structured outputs is not compatible with parallel function calls. When a parallel function call is generated, it may not match supplied schemas. Set parallel to calls false to disable parallel function calling. JSON schemas supplied with structured outputs aren't zero data retention eligible. I think they're just saying they're taking the data. Okay, and that's that. So, does anybody have any questions before we go into the examples? All right. So, this is how.
Okay. Just one thought. Okay. I mean, one question I have. Okay. I'm yet to go through the swarms understanding in detail, but does this affect this whole swarms, like, the concept and the architecture? Because swarms was trying to create a structured output on top of unstructured responses of the LLMs. I think that was the one part, right? So does this help you pivot better, or how does it affect this community?
Well, it affects everything because first, a swarm is only as good as the individual agents that power that swarm. So if you have models in a swarm that cannot process structured outputs, then they're pretty much useless. So having very structured outputs is very important because now you can have agents that, for example, in the examples that I'm about to show, you can have agents build other agents using function calling. And in fact, hierarchical swarm, where you have a boss and then that boss has workers, is function calling. You need function calling for that. But up until now, it was very difficult to implement because it was very non-deterministic. You needed the agent to be, correct, which was not. It wasn't the case 60% of the time. It was only right 40% of the time, which is not good. But now we can have an agent build agents and send orders to those agents in a very structured capacity. For example, now that we're getting into the schemas, so this is how the function calling model works. First you pip install swarms. So go to your terminal and then do pip 3 install swarms. Then once you have it, you can copy and paste this code, which let me paste it in the chat for you now. So we go here, playground, agents, tools, function calling. So I just pasted all the examples that we're going to go review, so you can check those out. So we're using Pydantic for validation. So here we're creating an agent spec. We're going to create an agent spec here. This has the name of the agents that we're going to make, system prompt, description, max tokens, temperature, context window, model name. So now with this spec, we can have the agent make an agent. And if we make a swarm spec, then we can make a list of those. We can make multiple. So multiple multiple agents. And so it's going to be a list of the agent spec. So basically we're using Pydantic for validation here. So here we're saying we want to make a list of these. So the list, a list of agents in the swarm. And yeah, so here, this is how you actually use the model. It's pretty easy. Less than 5 lines of code. You initialize it. You put the system prompts. We can make the prompt better by saying, think of relevant names, descriptions, and just make it more comprehensive. We can increase the max tokens to 3,000. We can make the temperature high, and then we can put the schema. So all we have to do is just copy the name of the schema, disable parallel tool use, and then we can say create a swarm of agents for programming. Actually, let's say create a swarm of agents to help us create a swarm of agents. What should we do? Any ideas? Create a swarm of agents to generate social media posts. Each agent should have its own social media. So this is like a marketing swarm, basically. We're gonna go here. We're gonna just clean this code a little bit, and then we're gonna run this. Just clean that a little bit. So now we're gonna run this, and now this agent is gonna make an arbitrary number of agents. Oh, let me move this out of here. Okay, so we run this, and then you're gonna see how it outputs the JSON. So boom, it made multiple agents. So now this is a hierarchical swarm, basically. Without function calling, having multi-agent collaboration is very hard. Very, very hard. So here it says multiple agents. So we have agent name, Twitter Wiz, system prompts, create a concise and engaging tweet that includes trending hashtags aim to capture attention and encourage retweets. Then we get a description, max tokens. Like it literally creates the entire agent for you. Like the whole thing. So I'll post that example in the chat now so you could analyze it on your own. So we can see here, this will output a dictionary, and we can count. Let's do it again. So count number of agents. So the output of this is going to be a dictionary. So we can say print out type out, and then we get the type, and then we're going to run it again. So this is so here it's created 5 agents. Now you could probably have it create more, but a big problem with tool usage right now is that you are fundamentally limited by the number of right now we are limited by the number of tokens that the model can generate. So tool usage is not very scalable now. Now the reliability issue is somewhat solved, but we have not solved the problem of generating massive amounts of tokens. Like this is only 3,000 tokens. Some tasks could be tens of thousands or even hundreds of thousands of tokens. So that might be an area of future research that would be very useful to essentially extend the number of function calls you can make, and multi-step function calls, that is. So yeah, Nicolas, would you like to present some examples?
Yeah, so since you started, I've been started to work on an example that I haven't actually finished, but I'm going to present this. Just give me a sec.
Nope.
Right, you should be able to see my screen now.
Yep.
So the example I wanted to present, and I'm going to finish it tonight. So it's nighttime for me too. I'm going to finish it tonight and share it in general on the server. So do check it out later today if you're interested. It's a simple example where I retrieve all my emails, all the daily emails that I've received on my Gmail account. And then I have an agent who is called Email Manager, who is going to be transferring emails to the right person. So for legal procedures, every legal documents, anything legal related, I'll transfer the email to the lawyer. And for other email, I transfer them to Kai. And so for this, I have created two functions, one transfer email to Kai and one transfer email to lawyer. And this one is to retrieve the email. And then the setup with Swarms is very easy. Basically, I retrieve all the new emails I've received today, and then using a loop, I'm going to create a task for each email to transfer the email to the right person. And I'm going to pass this to my agent, so to my LLM, for it to perform the right action. And so the way we're specifying tools is by mentioning in tools, transfer email to Kai and transfer email to lawyer. And so what's great is, so the agent is also very good at picking the right tool to use. So that's what I wanted to demonstrate, and I'll be sharing the code for this later. Another example I've been working on, I think could be interesting. I've put a bit more work on this one, is basically a project that from a list of open source projects is going to retrieve. So first of all, is going to summarize what each GitHub project does, each repo does, and then it's going to also retrieve contributors. And so the reason I'm doing this is because I want to structure this to be added to our CRM. And so I want to structure this in the format that you see here. So I have a name, a description, tags, the list of contributors, and the link of the repo. So this is a Pydantic model. And so what I have is I have a first agent, which is called Summarizer, which is going to summarize all the text from a GitHub repository. So explain what the GitHub repo is about in a short response with the provided URL. And this is using an LLM that runs locally on my computer. And then I have another agent who is using the new model, the new structured output model from OpenAI that Kai just presented, which is the project info generator. So I'm going to pass to this LLM some information about the repo and everything it needs basically to fill this Pydantic model. And from here, it's going to output Pydantic models directly in this format. And so this is very useful for my particular use case, because then I can store all of this into a dictionary I've called all projects here. And then I can save this to a CSV and import it to whatever CRM or tool I want. And so we could take this a bit further and have a tool that actually calls the API from my CRM to write the information about each project directly in the CRM.
That's super cool.
Yeah, it's pretty cool stuff. This will be probably either a workshop or a blog article that we'll be sharing on Swarm. So definitely check out the server on a regular basis, because I'll be posting about this here. You guys have any questions? All right. Well, I'll be sharing about this very soon, and feel free to ask questions in general, or join us in the voice channels in Forum or Swarms. We're here most days, if not every day, with Kai. So just feel free to join us and ask your questions.
All right, sounds good. Now I have a couple of more examples that I want to showcase, like the Claude artifact system. So some of you have probably been using Claude, and you've seen this new artifacts feature. Well, we built it from scratch using function calling. So here's a simple implementation of this, and basically like less than 20 lines of code considering the documentation. Here we're going to increase this quite a bit, and then we're also going to make this longer. So when you use Claude artifacts, let's try to do it right now. So if we say create a Python game, that uses a snake. No, actually, create an all new trippy Python game with no prior set mechanics. So basically, this is going to give you a function call. So the way that Claude Artifacts is working is that, well, first it gives you a summary, then it gives you the name, then it gives you the code, and then once you have the code, then it gives you a summary of what you're doing, and that's pretty much it. So an artifact really is, well, here we also see the Python. So it'll create, it creates a summary, it creates a code, it creates a file name, and we're essentially going to mimic this with the new function calling model that just came out. Now, before I do that, I want to see if this code runs and see like what actually happens. Because I've been trying to like create games from scratch using these models, like games that have never been built before. And I'm very curious as to what it built here. Wow. Okay, this is very weird. Oh wow. Yo, this is weird.
Yeah. This is art. You should create an NFT for this.
Yeah, man. Yo, what is this game? Okay, yeah, I got it. Okay, I know how to play now. Okay. Let's see. Let's try it again really quick. Bing, 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 bing. You know, it's actually surprising what the LLMs can do if you say, build something that's never been built before. Some people would say that they don't actually know what that means because they've only been trained on human data. But I don't necessarily think that's the case. I do think it is possible for LLMs to generate stuff that's never been seen before. So I'm going to show you what the Claude artifact schema looks like. So we're going to do this. We're going to import from Pydantic, import base model and fields. Then we're just going to kind of reverse engineer this. Where'd it go? Okay, here. I'm going to put that there. And, okay, so we have a summary. Actually, we could probably even make this better by saying, so name of the artifact, file name. Well, actually, we could also do a plan. So we can have a plan. Plan for the artifact. Do I generate a new Python file? So then, after we have the name, this is a name. Then we get the file name, file path, file name path. And this is going to be, for example, game.py. Then contents of the file. The content of the file, yeah. And then after that, you can also have edits, number edits count. So the edit count is how much, how many times the file has been edited. So, all right, now that we have this, we can try this out. So I'm gonna clean this up a little bit. Then we're gonna say create a game. Create a game in Python that has never been created before. Create a new form of gaming. Just we want to test out how novel this is. So we're going to run this, and then we're going to get the artifact. And so this right here is basically an open source implementation of the function calling schematic from Claude. It gives you a summary, it gives you a plan, then it gives you the artifact, which is the code. Then it also tells you to it also tells you how many times it's been edited. So we can run it again. And so this time we made a new one. Psychedelic Soundscape Explorer. Okay, let's see. What's the error here? So we're going to try something. There was an error with the parsing. We're going to run it again and see what happens. Okay, so it's generating. And would you look at that? Chronomorph, a time-altering puzzle game. Players manipulate time itself to solve complex puzzles. The game is set in a world where every object and character has its own timeline. What the hell? Players can speed up, slow down, reverse, or pause the time flow of individual elements to alter their environment and achieve level objectives. Huh.
So virtually there's no rule out there. You can do anything.
Basically, that's what it's looking like. But the output here is it doesn't actually look too good. So we're gonna quickly save this so we can remember this, just in case we ever lose this. And then we're gonna run it again so we can clean up the code and make it look nice and beautiful. So there's a function somewhere here that I made to clean up this output. Let's see. Yeah, okay, yep. I found it. So clean up code. We're going to create a new file just to clean this up and see. So we're going to take this and we're going to game time play. We're going to try running this now. Let's see. So now we need to find the code, schematic, contents. Okay. Think I've got it. Now we're going to clean up the code and then we're going to try executing it. All right, let's see if this works. Okay, it works. It's clean. Okay, now let's try running it. So we're gonna try exec cleaned. There's an error. Unexpected character after line continuation character. Oh. Let's see. Like I said, parsing is a little bit of an issue here. Because once the function is generated, you need to parse everything inside the function. Which is a little bit difficult. But yeah, let's see if we can let's see if there's something else we could do to get this code. So we're going to clear that up and then we're going to try cleaning this up again. Okay. Chronomorph game. Alright, we're gonna run it again because it's getting a little bit complicated. But the concept is very interesting. So we're gonna run it again, and we're gonna create a new artifact. But I also had Claude make a new one, so maybe we could try that out after as well. So, oh, I wasn't giving it the schema. I'm so stupid. Okay. So we're going to run that. It's going to generate the schema. And we'll be getting a response. So this game, as you can see here, is, let's see. Quantum, so the name of the game is Quantum Dimensions. Generate a new Python game implementing the concept. The file name path. Quantum Dimensions. A game of shifting realities. So we're going to copy this code. And then we're going to try and getting it to work. So we're going to do this. Bing, bing, bada boom, bada boom. So there seems to be a replicating issue here. Oh, yep, there, that's the problem right there. It was generating the code multiple times. All right, let's try it again. Okay, so this code looks pretty simple. Am I right? Now we can try executing this. So we're going to run that. And shifting dimensions. Well, let's just make a new file for this. So I don't think the code is actually incorrect. I just think, I think the parsing here is incorrect. So we can try and fix the parsing function, or we would just copy the code. So GitHub Copilot is gonna hopefully help us. Okay, let's see if that works now. Okay, it works. Wow. Okay. So welcome to Quantum Dimensions. Reality 1. Enemy empty. Enemy empty. Enemy empty. Enemy treasure enemy. What the fuck? Yeah, this is so weird. Alright, I'm gonna run it again, but I'm not gonna clutter up the terminal. Okay, so this is the game. I don't know what it does. It doesn't really say what it does. So welcome to Quantum Dimensions. Reality number 1. Empty enemy, empty treasure. Enemy treasure, empty enemy. Enter move. Up, down, left, right, or shift to change realities. Yo, this is insane. So I go up. Let's go down. Left. Can't move in that direction. Oh shit. Okay, so it says you've encountered an enemy in the last turn. Now it says can't move in that direction. So let's go right. You've encountered an enemy. Yo, this is very weird. But yeah, all right. So that's an example of the Claude artifacts. Now, there's a couple of other use cases that are very, very, very fun that I'm going to show you right now. So, again, if you go to the same folder, you can see a couple of use cases. If you go to Agents folder and Playgrounds, Tools, Function Calling, you can see more use cases. So here is a weather API function call that I was working on. So this basically will fetch the weather of a city, dates, and you'd also add country if you wanted to. And then another one for the Swarms Marketplace that we're doing now is we wanted to give you the ability to autonomously generate prompts from scratch. So we kind of built like an agent here that would generate you a prompt. So the prompt will give you a name, description, a prompt, tags, and use cases. Does anybody have an idea of a prompt they would like to make right now at this time?
I could use a prompt to write email greetings. Yeah.
Okay. All right, so we're gonna try this, and big bada boom. Let's see what happens. Well, actually, no, this is not gonna work right now because we need to pull it out of this folder. So something, nobody will tell you this, but if you git clone a project in Python, and there's also a Python version of that package, which here is Swarms, then there's going to be a conflict. So these example files, if you git clone the repo, you have to pull them into the root directory. So here it is. This is the prompt. Big bada boom. So let's see. Actually, I'll just put this prompt for you in the marketplace now, so you can, easily check it out or whatever. So let's see. Prompt name: friendly email greeter. Okay. So that's gonna be the name, then the description. A prompt for an agent to craft personalized and friendly emails that don't sound robotic or AI generated. So that's the description. Now the actual prompts. You're an expert at crafting warm and personalized email greetings. Your goal is to make the recipient feel valued and acknowledged. Follow these instructions. Start with the friendly greeting. Use the recipient's name to personalize the greeting. Mention something direct about the recipient or the context of the email if possible. Keep the tone friendly and approachable. Avoid sounding like a robot or using overly formal language. Then it'll give you a series of examples. So I'm going to post this prompt there. Big boom. Yep. See, but those the double N stuff is very annoying. So we're just gonna delete all of that stuff, and then I'm gonna post this. Okay. I don't know why it keeps doing this, like the slashes thing. Okay. So tags, email greeting, personalized, friendly. Now use cases. So basically, this agent here's purpose is to help you create prompts really well and post them on the Swarms marketplace. Pretty soon we'll be able to generate like tens of thousands of prompts for like various different use cases, like personal friend, email greetings, or finance, or basically anything, really, any prompt. And boom. So now this prompt is on the marketplace. And I'll share that with you in the general chat. And that's that. Look at that. Now we have a fully autonomous prompt generator. And that's very structured information. So in this schema here, I didn't analyze it, but there's a couple of things. We have the name, description, prompts, tags, STR, and then we have the use cases, which is a sequence of use case name and then descriptions. So this is pretty comprehensive stuff, alongside with the Claude artifacts. The Claude artifacts by far is the most complicated one we've seen. And then I also built a sentiment analysis one. So I was at a presentation a couple of days ago, and one of the presenters was trying to build entirely new, they were trying to build essentially like a sentiment analysis model from scratch using PyTorch, which is a very waste of time, because you could just use GPT-4 to conduct the sentiment analysis. But you couldn't do this previously because you needed extremely structured outputs, which wasn't easy to come by up until very recent. So we're going to run this. We're going to say we have some texts, and then we have the rating of the text. And then I'm going to take this out of here. And then I'm going to run this, and then it's going to rate this text, which is the hotel was average, but the food was excellent. It should be around a 0.7. And it gets it right. So the food was excellent. The hotel was average, 0.5. And then because the food was good, we're going to just, like average it out or something. Does anybody have an example they like to try? Let's see. This agent created the code incorrectly. It sucked. Let's try again and see what happens here. Yeah, 0.2. Like, this is pretty good. And if you make the prompt for this agent better, it would be much better as well. So this is very important. Sentiment analysis is very commonly used. Twitter right now is conducting sentiment analysis on every single tweet posted. So if it's too low, too high, or maybe if it's too low, then it'll probably be flagged in some kind of way. And then this is also how Facebook and Instagram work. So those are some examples. We're going to be having more workshops on this probably during this week because workshops, function calling is very important. And now that it's 100% reliable, now we could actually start building things that are reliable. It's insane. I've been working on so many new ideas and so many new things just like these past couple of days. And the other day I was building an app that could essentially build entirely new neural net model architectures. A very, very complicated task that only maybe less than 1,000 people in the world can really do really well. The Andre Karpathy's of the world, the Greg Brockmans of the world, and it's very hard. So this has just been a very simple glimpse into what's possible with the tech. And if you really want to see what's truly possible, you're going to have to just try and build yourself and see what happens. And keep trying. So if anybody has any questions or anything, let me know. I want to see what game the Claude made. The new game that Claude made, Psychedelic Soundscape Explorer. Let's see. Does anybody have any questions? Basically, the process is you make a schema, and then once you make the schema, then you just plug it in and you tell it to conduct the task that you want it to do. It's very simple, very, you don't need much Python experience for this. You just simply need to know how to make a schema, and then you'd also have another agent just help you build all the code, even if you want it. So, yeah. This game is weird. Very weird. Nicholas, would you like to speak on the future of function calling and how this can enable people to build their apps easier?
I think you've covered everything. Like you said, the most important thing, which is now there's many things that we can build that wouldn't be so easy to build before. Because for those who haven't tried before you would retry until it worked, and so that could get very expensive very quickly if the LLM wasn't able to output the correct output that you would expect. So yeah, having very reliable structured output is going to make many use cases viable in terms of cost, I'd say.
Yeah.
Also, I don't think we've read this part, but the article also mentions, the OpenAI article also mentions that this new model is actually cheaper than the regular 4.0 model.
Yeah, that's so funny, man. It's kind of funny because the code generation capabilities of the function calling model are much better than just regular GPT 4.0, or even GPT 4 period. I generated a lot of code and it was only incorrect maybe 1 out of 10 times.
That's crazy.
Yeah. So. Yeah, if you like Claude Artifacts, it's like this is essentially like an open source version of Claude Artifacts, which is very powerful because now that like the agent is getting agents getting really good at generating games or any type of like structured information. Email sending, that's structured. When you're sending an email, that's structured information. When you're using a new app, you know, like if you're using Airtable, putting data in, most things that we do on a daily basis on our digital devices are structured outputs. But now AIs have the capacity to do that. And that's really, really powerful. I'm still feeling like a little bit sick from whatever disease I got a month and a half ago or something. If I had more energy, I'd show you a couple of more things I'm building. But I'm getting kind of tired, and yeah, maybe I could create an agent to help me create drugs to help eliminate disease. But yeah. Let me know if you have any questions. This is mostly it for the demonstrations component of the workshop. If you want me to build a specific agent right now for you, and it's not too complicated, I could show you what that would be like right now. This is one of the projects that I was working on with the function calling agents. I created 220 agents to work on entirely new neural network architectures. And essentially provides the code for everything. It creates a theory. And the entire idea was to find the best new potential model architectures. So here's some of the code that it made, and we're going to try running it, and it actually works. Like I said, most of the code is really, really good. Like probably even better than human code. People love to talk so much bad stuff about AI code being bad, but it's like AI code is much better than the average human's code. which is good. That's actually good because then you can learn from them.
One thing. Could we generate a complete book, maybe in one pass with an army of, array of agents? Not multiple reviews, but give an idea, and then like it generates a finished quality book, ready to be published. Maybe 1 review, 2 reviews, max, with this structured output. Is that possible? I mean,
Yes.
just a thought.
Yeah, so I was trying something. Well, I wasn't trying something similar to this, but where is it? I just had it up. Where is it? So I was generating. So here's a data. This is a data sets of 200 different model architectures. Now there's a couple of things. You could do this page by page. So we're gonna create. Let's create a new file here. Book generator swarm. So it's going to run out of tokens. So what you can do, you can create a page schema. So class, you have a title, string, the title of the page, content. Or you could have a chapter schema, right? We can call this a chapter schema. And then what is a book? So a book is a series of chapters. We have a book title, which is going to be a string. Then we have a chapter, which is going to be a sequence of chapters, right? Because there's multiple chapters in a book. So we're going to take this, and then we can create a conclusion. And this is how you would essentially do it. Now you can have multiple agents generate multiple chapters, and then you can concatenate them. So you essentially so the agent can generate multiple pages. So if you wanted to do that, you would have multiple agents generate multiple chapters, and then you would feed the outputs of a chapter into the next agent. So say chapter.
And then you also need to have the reviewers, probably someone reviews each chapter or each section.
Yes. So say page. So what is a page? You have title. I mean, actually, you don't have a title. You have content, right? And then you have page number, which is going to be an integer. And then we could put this. So this is going to be a sequence of pages. So you would do one chapter, then feed that chapter into chapter 2 agents, then chapter 3, chapter 4, and then you can set like a limited number of chapters. But you would need multiple, so you would need an agent to output all this information into a dictionary. Then in the dictionary, you can stack them up as like a data set, which basically a book is a data set. So this is how you would do it. You would create an agent for every chapter, and then you'd feed the finished chapter into the next agent for every agent. Shit. Do you have a good prompt idea?
Maybe a children sci-fi book or something.
So we would create a loop, right? So for I in range, no. So we're going to create a list. Then the agents are going to make a chapter, right? So for let's see. How can we do this? Okay, I have an idea. First, we need to delete that. Then we're going to give it the task. So, okay, for I in range, 10 chapters. Fuck. I can make a demo for you. I could probably build this for you in maybe like tomorrow or Monday.
Yeah, that's fine. That's just a thought, okay? I mean,
It's
because this
definitely
can really
possible.
go wild. You can try that out.
So I'll give you some of the code I just made. You could probably have it make a couple of chapters, but like I said, you have to feed the previous chapters it made into the next agents or the next time it runs. So here's a simple script. You could probably even tell ChatGPT to do this, and it could probably help you help you faster than I could. But that's the schema you need. Now you're missing the logic. You're missing the logic to pass the agent outputs into the next agent, and then essentially, like I said, start stacking the responses and the chapters.
Yeah, I think we have to do all the role plays in typical agentic workflows. If I assign a work to an agency for publishing or writing a book, the set of probably the authors or for different kind of topics, how they collaborate, the reviewers, the creative people who kind of do the climax endings, and all those kind of role plays has to be there. We're woven into a typical agentic workflows. So I mean, for a really good output, I think
Yeah, absolutely. Yeah, so if you could send me like a specification, I could help you finish this up maybe like tomorrow or the day after.
No, this was just a thought. Maybe I can try that out myself. Okay, I'll come back to you for more useful use case. Okay, I mean this was just a random thought.
Oh, okay, cool.
Thank you.
Yeah, so that concludes today's workshop. If you enjoyed it, please share it, and please share our Discord with friends. Make sure people know about it, because we're trying to democratize this tech and make sure that anybody can use this technology to better their lives. So share this workshop in this Discord with your friends. We're probably going to be doing one. We will do one this next Saturday for sure. We might even do one during the week, but we have to find, we need to speculate on the time a little bit. So thanks for coming, and yeah, I appreciate you being here. If there's anything very specific that you want to build, just let me know, send me a DM, or just ask me, and I'll help you best as I can.
Yeah, thank you, Kai. Thanks, Nicholas. Thank you, everyone.
Yeah, thank you. Appreciate it.